The universe is infinite. No edge, no boundary, no end. Just endless space stretching forever in every direction. It sounds almost poetic, but there's a problem. Because when you look closer at what we actually know, the word infinite starts to fall apart. Let's begin with something simple. There is a difference between the universe and the observable universe. The observable universe is not everything. It's just the region of space from which light has had enough time to reach us since the Big Bang. About 13.8 billion years have passed. But because space itself expands, the observable radius isn't 13.8 billion light years. It's about 46 billion light years in every direction. That forms a sphere, a cosmic horizon. Beyond that horizon, there could be more galaxies, more stars, more structure, but we cannot see them. No light from beyond that boundary has reached us yet. So when someone says, the universe is infinite, what they really mean is, we don't see an edge, and those are not the same thing. Not seeing an edge is not proof that there isn't one. It simply means our observable patch looks flat and uniform. And that brings us to the first key detail: measurements of the cosmic microwave background. The oldest light in the universe suggests that space is extremely flat. Flat geometry implies one of two things. Either the universe is truly infinite, or it is so large that its curvature is too subtle for us to detect. Imagine standing on Earth. From where you stand, the ground looks flat. You don't see curvature. But Earth is not flat. It's just large compared to your perspective. Now scale that analogy up. What if the universe is curved, but on a scale so vast that our observable sphere is just a tiny patch of something much bigger? In that case, the universe could be finite, without having an edge. That sounds impossible at first. Finite but no edge? But geometry allows it. A 2D creature living on the surface of a sphere would never encounter a boundary, could travel forever. It would never fall off. Yet its world would still have a finite area. Now imagine the three-dimensional equivalent of that surface. A hypersphere. No edge, no border, but still finite volume. If that's true, infinity disappears. And with it, one of the strangest consequences of modern cosmology. Because here's where things get uncomfortable. If the universe is truly infinite, then everything that can happen must happen. Infinitely many times. There would be infinitely many galaxies, infinitely many stars, infinitely many Earth-like planets, and statistically, infinitely many copies of you. Not metaphorically, mathematically. Given infinite space and finite possible particle arrangements, configurations must repeat. Somewhere unimaginably far away, another version of you could be living an identical life, or a slightly different one, made a different choice, turned left instead of right. This isn't science fiction. It's a direct consequence of spatial infinity. But if the universe is finite, that conclusion collapses. No infinite repetition, no endless duplication, no cosmic copies. The difference between finite and infinite space isn't just about size. It's about whether reality repeats itself. Now here's where the tension increases. Current cosmological models, especially lambda CDM, do not require infinity. They allow it, but they don't prove it. Inflation theory, which describes a rapid expansion in the early universe, predicts that space became extremely large, possibly far larger than what we can observe. Some versions of inflation even suggest eternal inflation, where new regions of space keep forming. That leads to multiverse ideas. But here's the key word: suggest, not confirm, because we cannot observe beyond our horizon. And without observation, infinity remains an assumption, an extrapolation, not a measurement, and that leads to something deeper. Infinity is not a physical observation. It's a mathematical concept. We are extremely comfortable using infinity in equations, but nature does not automatically obey mathematical elegance. Physics is full of infinities that later turned out to signal incomplete understanding. Infinite density in black holes, infinite curvature at singularities, infinite energy in quantum fields. Often, when infinity appears in physics, it means our theory has reached its limit. So maybe the universe being infinite isn't a discovery. Maybe it's a placeholder, a statement that says, we don't know how big it really is. There's another subtle issue. If the universe is finite but unbounded, this topology could leave imprints, patterns in the cosmic microwave background, repeating temperature fluctuations, circles in the sky. Scientists have searched for these patterns. So far, no conclusive evidence. But the search itself tells you something important. Infinity is not settled. It's still open, still questioned, still debated. And that uncertainty changes how we think about reality. Because if space is finite, then everything that exists is contained within a limited volume. Cosmic total, a definable amount of matter, a maximum number of particles, a limit to possible arrangements. But if space is infinite, then reality has no total size, no maximum, no boundary, no ultimate containment. One version implies uniqueness, the other implies inevitability. And here's the part most people miss. Both options are deeply strange. A finite universe with no edge defies intuition. An infinite universe defies probability. Either way, reality is not simple. So when we say casually, the universe is infinite, we're not stating a fact. We're choosing one interpretation of incomplete data. And the truth is, we don't yet know. Maybe space goes on forever. Maybe it curves back on itself. Maybe it's vastly larger than we can imagine, but still finite. The observable universe is all we can measure. Everything beyond that is inference. And until we detect curvature, or topology, or something unexpected in the cosmic background, infinity remains a possibility, not a certainty. The universe may have no edge, but that doesn't automatically mean it's infinite. And if it isn't infinite, then reality is far more contained and far more singular than we ever assumed. And that changes everything.